Okay, in this video, we're gonna talk about the limit of transcendental functions, particularly the limit as x approaches infinity. Okay, let's have an example. If we have a limit of 3 to the x as x approaches positive infinity, so what would be the limit of this? So that's a very simple. If we are going to use algebra, we just replace x by a positive infinity. So that's 3 to positive infinity. What would be the result? So as you can see, if a number greater than 1 is raised to a very, very large number, this means that the result is a very, very large number. And that is why the limit of this is a positive infinity. Okay, let's say we have the limit of 2 raised to x plus 1 as x approaches positive infinity. So this is the same. Why? Because when a positive infinity is added by 1, the result is still a positive infinity, a very large number. When 2 is raised to a very, very large number, the result is still a positive infinity. Okay. Take note that this is true when the base is greater than 1. What if we have the limit of 1 half raised to x as x approaches positive infinity? So recall our law of exponent. This is the same as the limit 1 to the x is still 1 over 2 raised to x as x approaches positive infinity. And we have 1 over 2 raised to positive infinity. So we know that when 2 is raised to a very large number, like positive, which described as a positive infinity, the result is positive infinity. And we know that when a very small number like 1 is divided by a very large number, the result is 0. Okay? So the result here is 0, or the limit of 1 half to the x as x approaches positive infinity is 0. How about the limit of e to the negative x as x approaches positive infinity? So as you can see, if we replace x by a positive infinity, the result is negative infinity. Okay, that's correct. A negative infinity, because we have a negative here. And using the law of exponent, that is e to a positive infinity. And as you can see, the result is also 0, because when 1 is divided by a very large number, the result is 0. So that's how to evaluate the limit for exponential function. Okay? How about we have the limit of ln of x as x approaches positive infinity? What will be the result? Okay? That is a positive infinity, right? Because the graph of this function looks like this. Okay, like this one. As you can see, as x gets to positive infinity, what will happen to the value of y? So it gets higher and higher, right? Okay, so that's why it is a positive infinity. How about the limit of logarithm of x, let's say base 2, as x approaches 0 from the right? Why do we need to put 0 from the right, or a positive? Because we do not have 0 from the left. Because the logarithm is defined only on 0, on positive real numbers only. Not 0 and not negative. So positive real numbers only. So kaya 0 from the right only. So by looking at this one, if we're going to graph, the graph of this also looks like this, Then from the right, 0 from the right going down here. So what would be the limit? So the limit is a negative infinity. So therefore, we can conclude here that the limit of any logarithm base b as x approaches 0 from the right as always a negative infinity. And for here, this is also the same as the limit of ln of x, sorry, log any logarithm of x base b as x approaches positive infinity, the result is always a positive infinity. So that's how to evaluate the limits of exponential and logarithmic functions involving infinity.